Greetings, ladies and gentlemen. My name is Ryan Shazani, and welcome back to another physics video. In this video, we'll be explaining or we'll be tackling the question of when we're given a cup of water and the cup is uniform. And in the cup of water, there'll be a cube of ice, and above the ice will be a metal ball. Now the question is, what happens to the height of the water level when all of the ice has melted? Will the height increase or decrease or stay the same? Now, the way we're going to tackle this question is to not actually compare the initial height of the water and the final height of the water. We're going to find something, any other variables that could represent the height itself. Okay? And the way to do that is actually to compare the initial volume of submerged items and the final volume of submerged items. Why? Because if you think about it, because the cup is uniform, so the more items that are submerged or the more things that are submerged, the higher the water level. And the less things that are submerged, or the less the volume of the submerged items, then the height will be less. So let's take a look at the submerged items or the submerged volume initially. So if this is the mass of the ice, or this is the cube of the ice, then the submerged part of the ice, we'll call it mx, and the non-submerged part will be my. And we can see that the upthrust due to mx is equals to rho of water, which is the density of water, times the volume of x times g. Okay? And this upthrust is also equals to the mass of the metal ball and the mass of ice, right? So rho w, or rho of the water, times vx times g is equals to the weight by the ice, so mi times g plus mb times g. And you can simplify this equation to be rho w vx equals to mi plus mb. Alright? Now, what are we exactly comparing? We're comparing the volume initially, so volume of submerged initially, and this is actually equals to just vx. The volume of submerged items finally is equals to the volume of the melted ice plus the volume of the metal ball. Why the metal ball? Because the metal ball is denser than water and therefore it will sink. Okay? And therefore it will be submerged in the water. So we are comparing which one is greater and which one is smaller. So I'm just going to call this Vs, I, and this will be equal to Vs, F. We want to find whether Vs, I is greater or smaller than Vs, F. And Vs, I is just this, right? You can make this Vx the subject, so mi over rho w plus mb over rho w. So this is mass of the ice over density of water plus mass of the metal ball over the density of water. Now, we can also take note that the volume of the melted ice is just equals to, so remember density is equals to mass over volume, so volume is equals to mass over density. And this is just mass of the melted ice, mi, over density of water, right? And therefore I can say that Vs, F is equals to the mass of the melted ice, or the volume of the melted ice, which is mi over rho w, plus the volume of the metal ball, which is just mb over rho b. And remember, density of the metal ball is greater than density of water, obviously, because it will sink. Therefore, we can say that mb over rho b is smaller than mb over rho w. And because this is smaller, therefore, the final volume of submerged items, VSF, is smaller than the initial volume of the submerged items, VSI. And what does this mean? It means that the height of the water level would actually decrease after all of the ice has melted. If this video helped you, if you found this video enjoyable, then make sure to subscribe to my channel, like the video, and share the video. Other than that, thank you for watching, and I'll see you in the next video. Goodbye.